Hello, everyone. We are going to continue working with chapter 6 today, and we cover section 6.4, inverse trigonometric functions and right triangles. Well, we're going to just learn how to simplify our life with use of right triangles. What is inverse? You probably remember from the the chapter where we were covering all the functions, that inverse function is returning you actually argument which you use to calculate a function. Let me kind of explain it on example. So what is inverse? If you have y equals sine of x, so you take some x, calculate sine of it, and that's going to give you y. What is going to be inverse? Inverse is going to bring you back to x. It's going to try to find what was x if somebody knows y. So somebody gives you y and asking what was x I used for this equation. And that's inverse, right? How it will work on triangles? Well, on triangles, it's going to simplify our life. And instead of using identities, we are just going to visualize finding sine, tangent, and cosine using triangles. Let me kind of explain it on example. Imagine that we have a right triangle. Remember that we are working right now with right triangles. And right triangle has hypotenuse, side A, side B, right? And I'm going to label the angle over here as angle theta, right? We know that sine of theta equals opposite side over hypotenuse, right? Opposite side over hypotenuse. So what does it mean? If somebody gives you opposite side and hypotenuse in some triangle, you can calculate sine of theta, right? You just can divide them and calculator is going to give you a number. Now, you don't need a protractor to measure angle theta anymore. You can just use the same calculator and say that theta, according to this equation, is going to be sine inverse of B over C. So actually for right triangles, you don't need to use protractor anymore. You just can use your calculator. You measure the sides of right triangles, like B and C. Here you don't need all sides, just two of them, right hypotenuse and opposite side. Divide them, find the number, and then use a calculator and find inverse of this number, just like we do for x over here. And that's going to give you the value. Let's consider example. Let me change the color. I don't like the pink one. Let's use blue. So, sorry. Let's start with example. So consider example 1. Well, imagine that somebody gives us a right triangle with sides b equals 1 and hypotenuse equals 2. And you don't know the angle, but you just have a ruler and measure the sides. You always have a ruler, right? It's much easier to have a ruler than a protractor. Can we find what was the angle? Well, we recall that opposite side and hypotenuse are connected by function sine, right? So sine equals 1 over 2. Well, now you can recall that from the table, you know that theta, which gives you sine equals to 1 over 2, you can use a table, right, is going to be what? I'm going to write it down formally, but you already probably remember that it's going to be like 30 degrees or pi over 6. And basically without any protractor, you already know the angle, right? What if your number is not in the table? Another example. Let's consider something from not table values. Imagine a different triangle and the sides are 5 and 3. Still want to know like what is angle theta. Again, use the same equation, write down that sine of theta equals b over c, in our case 3 over 5. And same way, theta is going to be sine inverse of 3 over 5. The only bad thing that 3 over 5 is not in our table. There is no value for theta, which is like 3 over 5. What should we do in this case? In this case, we are supposed to use a calculator. What I'm going to do, guys, I want to show you like how it looks on calculator, but I have to do a different like application on my computer. Give me a second, guys. So I'm going to turn on the calculator. Where is it? Okay, and choose a calculator as my next application. Cannot find it, actually. It does not give me the calculator. one more time. Give me a second, guys. So let's do, yeah, there it is. So I'm going to show you like how it works in calculator. So we do have calculator, right? So, well, what we do, we take 3 divided over 5, get our number. Number is 0.6, right? Then on my calculator, on my computer, it's trigonometry. And in trigonometry, I have a function secant. Secant means that you can either have sine, cosine, tangent, and secant and cotangent, or you can have inverses. Secant means that all of them are going to turn into inverses, right? Sine inverse, and it's going to give me the number 36.8, or better say 0.9, right? Is it going to be the radians measure or degrees? Important to know, right? Well, let's look over here. You see degrees over here, means that it's going to give you the value in degrees. So we have 36.9, and I'm returning back to my kind of original screen. And let's write it down. So 36.9. Okay, give me a second. It's still here, right? So write down 36.9 degrees. Okay, so even if you kind of don't have a table or don't remember a table, you can use a calculator and always find actually the angle just using the ruler, right? Okay, let me remind you how the table, not table, but how the function and domain and range are connected. Here, it's important to know it just because I'm planning to show you a composition of inverse and direct functions. So I'm going to maybe write it down over here, change the color. Let me do it. Okay, let's do the pink. So I'm going to write down function here. This table is in your book. Here I'm going to write down domain. And here is going to be range. Okay, guys, for sine inverse of theta, what is domain? Well, domain is going to be what are the values sine is giving to you, right? Remember that sine changes from -1 to 1, so domain is going to be -1 to 1. What is going to be the range? If you recall how we were drawing the functions and we're trying to find out where the sine is 1 to 1. Generally, sine is not 1 to 1, so it does not have inverse. But if you cut it from negative pi over 2, 2 pi over 2, this part of sine is going to be 1 to 1, and that's going to have an inverse, right? So that's going to be the range. Range is like possible values which sine inverse can return. Now, what is going to happen for cosine? Well, cosine is going to be slightly different. Usually we used to have like almost everything same about sine and cosine, but here the domain is still going to be from -1 to 1 because the values cosine is returning is -1 to 1, but range is going to be different. It's going to be from 0 to pi because cosine is 1 to 1 from 0 to pi, not from minus pi to pi over 2, minus pi over 2 to pi over 2. What is tangent? Tangent inverse. What is possible values tangent returning? Well, tangent, we remember, can return values from negative infinity to positive infinity. So tangent inverse is going to have the mean from negative infinity to positive infinity. I should write down square brackets. Sorry, accidentally was using wrong brackets. Well, infinity is integral. So what is going to be range? What are the values of tangent like? What are the angles which you can plug in tangent and still be 1 to 1? Remember, the tangent is a repeated function many times, right? So generally, tangent is not 1 to 1, but if you consider just one branch of this function from negative pi over 2 to pi over 2, it's 1 to 1. So I'm going to put it as negative pi over 2 to pi over 2. It's almost like sine. The only difference is for sine, we do include pi over negative pi over 2 and pi over 2. For tangent, no, because it's going to go to infinity. Remember that tangent of pi over 2 goes to infinity and tangent of negative pi over 2 goes to negative infinity, right? Okay, now I'm going to show you some examples of use of these tables and right triangles. Let me move to the next page. Let me change the color. So next example, example 3, solving an equation with non-table values. Solving an equation with non-table values. What I mean? Well, for example, somebody gives you an equation, sine of theta equals 0.4. And 0.4, you know, that's 4 over 10, right? 4/10, or 2 over 5. And 2 over 5 is not in a table, not in our table. What should we do? Well, first, we are going to draw a unit circle and see what are the options. Well, in unit circle, 0.4, remember that it's y coordinate of a point, right? 0.4 is y, so y equals 0.4. And on unit circle is going to produce two angles, theta 1 over here and theta 2, the angle over here. Well, what we can do, guys, we can calculate theta 1 easily. How? Well, if you do know sine, so we are just going to take sine inverse of 2 over 5, and that's going to give us theta. That's going to be theta 1. So I just kind of took a calculator to not switch anything, and that's approximately 24 degrees. Now, this is going to be this little theta, right? It's obviously, right? 24 degrees does not look like theta 2. So how do we calculate theta 2? We remember that this theta 1 and the little angle over here, let me use a different color, this little angle over here are same, this theta 1 and the little angle over here. So to calculate theta 2, we just need to subtract theta 1 from like 180 degrees, right? So we take 180 degrees and subtract 24 degrees. We are going to get 156 degrees. That's going to be our theta 2. If somebody is asking you to find all solutions of this equation on interval from 0 to 2 pi, that's going to be the answer. But if somebody is asking you to find all solutions, how do you do this? For all solutions, we remember that it's going to be theta 1, 24 degrees plus 2 pi k, right? Because the function is periodic, it's going to repeat itself. Like if you go at 2 pi, it's still going to give you same value here, right? Because like 24 degrees plus 2 pi, you are going to get the very same 0.4, just because 2 pi is a period. The only bad thing here is that we are mixing over here degrees and radians, which is not good. But we do know that 2 pi is 360 degrees. So if you wish to give your answer in degrees, it's supposed to look like this, 360K. If you want to give everything in radians, then you have to convert 24 degrees in radians. Usually you do this when you are in calculator mode. Just switch to radians and you are going to get this answer in radians. It's supposed to be around like 0.5, 0.4 radians, so not very difficult to find. Okay, now what is going to be theta 2? Theta 2 is 156 degrees plus we're already going to use like 360K. And K here is integer, right? Well, we just solved this equation. What else can we do using triangles or using like this inverses functions? We can compose trigonometric functions and their inverses. So let me kind of change the color and give it a different title. Maybe I should use a text here. Where is my text? Yeah, let me write it down. Okay, so I'm going to teach you how to compose trigonometric functions and their inverses. You probably tell me that, okay, we do know how to compose them, right? We do know cancellation equations, that if you take direct function and then inverse function from it, you are going to get the argument. And that's correct. But it works when direct function and inverse function are kind of same function. For example, if you have something, give me a second, I'll turn to the writing mode. So if you have, for example, sine inverse of 1 over 2, easy to compose it, right? You kind of tell that that's 1/2. Sine and sine inverse cancel each other. You have to check for range and domain, so you are not going to get that number here like 5, for example, because sine is never equal to 5. So if somebody gives you 5 over here, it's not going to work. But generally speaking, that's how we do this, right? We just cancel direct and inverse function. We remember that sine inverse of 1/2 is pi over 6, and sine of pi over 6 is 1/2. What should we do if they are not matching? Not matching. I'm going to write it down. Not matching. If they're not matching like this, you calculate sine of tangent inverse of 1/2. You cannot cancel them just because they are different functions, right? Cancellation equation works for the same function, not for two different functions. How are we going to solve it? Well, guys, first, because this one, tangent inverse gives you the angle back, right? That's going to be theta. So tangent inverse of 1/2 equals theta, from where we can say that tangent of theta, because they are inverses, is going to be 1/2, right? Good. Now, I'm going to draw a triangle with these numbers. So 1/2 is opposite side is 1, adjacent side is 2, and there is angle theta. What do we need to find? We actually need to find sine of this theta, right? Because like if you plug in this theta over here, sine of theta. Can we find this sine from the triangle? Very easy, right? We just need to know hypotenuse. Let's calculate hypotenuse. Hypotenuse is a square root of 2 square plus 1 square, which is going to give you square root of 5. So sine is going to be what? Opposite side, which is 1 over square root of 5. And we are fine. We already found the answer. Very easy, right? And you don't need to use any identities anymore because you can use triangles. You have to be careful with range and domain. Here, everything is clear, right? The tangent inverse of 1/2 is going to be in the first quadrant. So sine in the first quadrant is going to be positive number. But sometimes it's not going to be the case. Let's consider two more examples. And I'll need to change the page. So I'm going to change the color to, I don't know. Okay, let's do this. So example number two. Let's calculate cosine of sine inverse of -1/3. You see, more complicated question. So first, we call this theta, right? And then we can write down that sine of this theta equals -1/3. Well, let's draw a triangle here and label the sides. For now, don't bother with minus. We are going to talk about minus a little bit later. For now, just kind of consider numbers. So opposite side is 1, hypotenuse is 3, right? What is going to be adjacent side? Well, we remember that 3 squared equals 1 squared plus, if we call it a square, we can calculate that a square equals what? 3 squared is 9, minus 1, we subtract this 1, and then a is going to be a square root of 8, right? So we know all the sides of this triangle. That's a square root of 8 now. How to calculate, let me erase now my question marks, sorry, and write down like what it's supposed to be here. So we do have cosine of theta here. So what is cosine of theta in this triangle? Well, cosine is opposite adjacent side, which is a square root of 8 divided over hypotenuse. We are almost done. Now we are going to talk about the minus. What should we do with the minus? To work with minus, we are going to draw a unit circle, or you just can draw like coordinate plane. What is sine? We remember that sine inverse range, so returning values, the thetas which sine inverse can return are going to be here. Remember the previous table, sine inverse changes from -pi/2 to pi/2. So actually my theta can be either this or this. How do I know like where my theta is? Is it sitting in the first quadrant or fourth? I know that in the first quadrant, the sine is positive. So it's not going to be the first quadrant. It's going to be sitting here. So my theta is this angle. That's going to be my theta because it's negative, right? The sine is negative over here. Sine is negative here. Okay, now what is going to be cosine here? Cosine here is positive, and we are lucky we don't need to add anything here, and that's going to be our final answer. Okay, so, but we have to check it. I'm going to write it down that cosine is greater than 0 in this quadrant, so we don't need to change the sign. Well, one more example, and we are almost done. Let's do example 3. That's going to be our last example in this section. So tangent of cosine inverse of -1/3. I'm trying to do different combinations of sine, cosine, and tangent. So remember the steps. Call it theta, right? And write it down as tangent of theta. Remember that if cosine inverse equals to theta, then cosine of this theta equals -1/3. Draw a triangle and don't consider minus yet. So theta here, 1 is adjacent side, 3 is hypotenuse. Well, because we do have 1 and 3, then opposite side is going to be a square root of 8, right? We square 3, it's 9 minus 1, it's square root of 8. Now we can find the tangent, and tangent is going to be like opposite side, which is square root of 8 over 1. Now we need to talk about minus. To talk about minus, we are going to draw again coordinate plane, right? We remember that cosine, let me change the color to blue, for example. Cosine inverse is defined over here only. Cosine inverse can return you values from 0 to pi and nothing else. What are the signs of cosine? Cosine is positive here and negative here. Because we do have -1/3, means that my angle theta is over here. That's my theta. What is going to be tangent? Well, let's draw a kind of plane for tangent. Remember that tangent is alternation, plus, minus, plus, minus, plus. And over here, tangent is also negative. So because tangent is negative, I'm going to put minus here. I'm going to label that this is tangent of theta. This is cosine of theta. Again, for cosine, we don't consider the whole plane just because cosine inverse does not work for all 4 quadrants. It works only for first and the second one. And that's going to be the minus extra. Well, you don't need to write it down like square root of 8 over 1. You can write it down just minus square root of 8, right? Just because 1 is just division. Division by 1 is not changing expression. What else? Well, you can kind of modify it a little bit by kind of extracting a square root of 4 here. Again, it's not necessary for me, but I know some people are going to do this. So I'm going to write it down, 2 square roots of 2. I represent 8 as 4 by 2 and extract a square root of 4. Square root of 4 is going to be 2, right? A square root of 2 is going to stay. So it's 2 square roots of 2. If you don't know how to do this yet, okay, just leave it as square root of 8. I'm going to be happy with this. Well, I think that's all for this section, and do your homework, okay? Okay, let me finish my recording.